Hello and welcome to this training on spring hanger selection in AutoPipe. There are many different types of supports that can be represented in the pipe stress model. While some are known and rigid restraints, others have loads changing or displacement variations. The addition of supports is essential for restraining the system's weight, and it can be easily achieved using rigid restraints. But this increases the stiffness of the system and consequently increases the thermal expansion stresses. So often a compromise is required, and the pipe stress engineer must determine where rigid restraints can be used, which are normally more economic, or where variable spring hangers, constant spring hangers, or snubbers have to be used. A simple resting type of rigid support can also have liftoff that occurs, so sometimes more control is advisable. Pipe operational liftoff means that the restraint is no longer providing the weight support, so it renders the gravity case inaccurate. To carry the weight without affecting the expansion stresses too much, we can use variable spring hangers. This is basically a simple coiled spring where the load increases as the amount of displacement increases. They're relatively inexpensive, but they are load varying, so this can be a drawback with large displacements. And there's various types of variable spring hangers, and they're all slightly different. So as an example, a type 21 is a standard spring with an upper connection for suspension. A type 29 is usually under the pipe with a proper can. And a type 79 usually uses a trapeze with twin springs. There are also constant spring supports, which have an arrangement of levers and cams that provide a fixed amount of constant support force. These are more expensive supports, but they're ideal for where pipe movements are large and the sensitivity of equipment is important. So as an example, in a main steam line. And they also have different types of these for different applications. The AutoPipe spring hanger selection process will determine what spring should be used at a particular location to accommodate the weight and the thermal expansion. Keep in mind that it only considers static loads. Springs offer hardly any additional stiffness, so they're really quite ineffective in dynamic events. Within AutoPipe is the vendor data for variable springs, and it can run a spring hanger selection procedure for springs identified as undesigned in the support dialog box. The objectives of the hanger selection are to choose a spring which will provide the necessary weight support to balance the piping system as it moves from its cold installed state to its hot operating state. It also has to permit the total operational movement of the pipe as it goes from cold to hot, and it shouldn't cause excessive expansion stresses in the pipe as the spring load changes from cold to hot. For any spring where the user knows the stiffness and the cold load values, the undesigned check can be removed, and the data can be entered into the input fields in this dialog box. The load variation is a factor used in the spring selection to help limit the expansion stress. It can be set individually here in this dialog box or globally overwritten before the hanger selection process is run. In some designs, and especially in small bore pipelines, the support hardware can add a significant weight and it can affect the spring selection, so the weight can be added in this dialog box at the support definition stage. And also a cold load design is possible instead of a hot load. This provides for more balanced loading on equipment during installation in systems that involve hot gas piping around pumps or gas piping around compressors or steam piping around turbines. An anchor can be released in any direction for the gravity load case during the hanger design process. This allows a hanger near the anchor to be designed such that the hanger supports the gravity load. For example, this approach is often used to ensure that nozzles are relieved of any gravity loads. The vendor can be identified by using the Analyze Hanger Selection option. Other settings for the selection process can be set here, including the rigid hanger criterion and the global load variation. And this check can be carried out for a number of thermal cases, all selected by the user. If the Show Hanger Report checkbox is checked on, a report will pop up after the hanger analysis is ran to review the report. So let's look at the spring selection procedure. First, a rigid restraint or a V-stop replaces the hanger for the gravity load case, and any anchor releases are applied to the model. The calculated support reaction is what's considered the hot load to be carried by the spring hanger. Then the rigid restraint is removed for the thermal load cases and no anchors are released. The magnitude of the vertical thermal displacement that's calculated is considered the free travel distance. If AutoPipe finds that the support moves up under the gravity load, it will report that the spring is not required. And if the travel distance is less than the specified rigid hanger displacement criterion, a rigid restraint is selected. AutoPipe then uses the calculated hot load from step 1 and the travel distance from step 2, and the cold load is calculated using a spring rate from the specified spring manufacturer table. If both hot and cold loads are within a spring's operating range, that spring is reported as a working spring. Otherwise, the next size in the table is checked. Lastly, the spring load variation of the selected spring is checked against a user-specified permissible load variation. If the spring passes all of these steps, that spring will be shown on the spring hanger report as a working option for the model. If no spring is found, the process is repeated for multiple springs under that manufacturer. And if in the end no spring is found, a constant force spring hanger will be selected. The report will show all possible springs, and the first one in the list will be used in the model. So this just shows an example of a spring table from a manufacturer. In this case, it's an example from Anvil. The hanger dialog, as we mentioned, is used to set up the hanger selection analysis. So the user has to input some criteria, including the operating cases the hanger should be designed for. The rigid hanger criterion is used for deciding whether to use a rigid V-stop versus a spring hanger. And AutoPipe will select a rigid hanger if the thermal movement at the support location is less than 0.1 inches or 2.54 millimeters per the default settings, because this is a reasonable value for design. The load variation ratio is the ratio of the difference between the hot and cold spring loads to the hot load value. A 25% variation between cold and hot loads is a reasonable value, but you may select a smaller value for some systems. And if AutoPipe can't find a hanger that satisfies this load variation ratio, it will select a constant support, which has a 0 variation between hot and cold loads. When you select the Show Hanger Report option and you check that on, you'll see a report that looks like this. The springs that meet the selection criteria will be listed in this report, and the first in the list is indicated with an asterisk. This first hanger that's listed is the one that will automatically be assigned by AutoPipe. So if you look back at the dialog box for the support, you'll see this information is automatically updated in the support dialog box. If you wanted AutoPipe to consistently use these values, you have two options. You can turn off the hanger selection in the Analyze All dialog, which is shown in the middle, or you can remove the Undesigned check from the support dialog, which is shown on the right, and this will fix the spring properties. In this case, the load calculated in the gravity case is taken as the cold load, and the hot load is then less because it has the spring rate times the displacement subtracted from it. The load variation calculation also changes a bit. If you have some operating conditions, you might be interested in the maximum loads, so you can use the non-code combinations tab on the load combination dialog box to set up the desired results. Remember that only vertical loads will appear at spring supports when you're looking at the support forces. Now let's jump into the program and go through our example using our workbook.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.